All right, everyone. This video will cover notes from section 7.6. And 7.6 deals with radical equations. We'll be solving radical equations. And I want to remind you about the square root itself. When you're calculating the square root of a term, remember that squaring a number and taking the square root, those are opposites of each other. So in order to solve equations, remember we use those inverse operations. We always do the opposite operation or the inverse operation to solve. In this first example, we have the square root of x equals 4. And we want to know what is that number that you take the square root of in order to get 4. So to solve this equation, we would do the opposite of taking the square root. The inverse operation is to square the square root of x. And whatever you do to one side of the equation, you must also do to the opposite side. So we have to raise both sides of the equation to the second power. And when we do that, the square root of x raised to the second power, that gives you x. This 4, when we raise 4 to the second power, we get 16. So this is our solution. X is equal to 16. When we take the square root of 16, we get 4. Now you can always check your solutions by plugging in the number that you get for x back into the original equation. And then you calculate it. So in your calculator, you would substitute the square root of 16 and you're checking to confirm that you get 4. All right, in the next example, you see the square root of 3x plus 7 equals 5. So to solve, we're going to square the left and the right sides of these equations, of this equation. So when we square the left side of the equation, that just removes the square root symbol. Because remember, squaring a number and taking the square root are opposite. So it just removes the square root symbol. And we get 3x plus 7. On the right side, 5 squared gives us 25. We'll solve this equation first by subtracting 7 from both sides. The 7s will cancel on the left, leaving 3x. And on the right side, 25 minus 7 gives us 18. We would divide. You want to divide both sides of this equation by 3. Now, when we do that, the 3's are going to cancel. On the left, leaving x, and on the right side, 18 divided by 3 gives us 6. 6 is our solution. And of course, you can check your work. Go back and substitute 6 for x, and underneath that square root, you'll get 3 times 6, which is 18, plus 7, that gives you 25. You check it, take the square root of 25, you'll see that it does equal 5. Now in this next example, we have the cubed root of x equals negative 4. So to get the inverse of cubing a term, you want to raise, or get the inverse of taking the cubed root of a term, you want to raise that term to the third power. So we're raising both the left and the right sides of this equation to the third power. And when we raise the cubed root of x to the third power, we just get x. It just removes that cubed root. We get x by itself on the left side. And on the right side, negative 4 raised to the third power gives us negative 64. This is our answer. Now for the next example, we see x equals the square root of x plus 6. So we got to get rid of this square root. The opposite of square root, we're going to square both sides of this equation, raise them to the second power. And when we do that, on the left side, x to the second power gives us x squared. And on the right side, we just remove that square root symbol. We get x plus 6. We'll solve the equation by combining all terms on the left side. So we're going to subtract 6 from both sides of this equation and subtract x from both sides of the equation. So we'll get 0 on the right. On the left side, we now have x squared minus x minus 6 And this is a trinomial. We're going to factor this trinomial using our two sets of parentheses. And we're going to factor the x using x and x. So we use x and x to get x squared. And we'll factor the minus 6 using negative 3 and positive 2. Now remember, your next step is to take each of those factors and set them equal to 0 and solve. So that first factor on the left, x minus 3 equals 0, or the factor on the right, x plus 2 equals 0. We'll solve both of these equations. On the left, we're going to add 3 to both sides of the equation. We'll get x equals 3. And on the right, we're going to subtract 2 from both sides of the equation. We'll get x equals negative 2. Now, x can be 3. If we substitute 3 underneath the square root, we'll get 3 plus 6. That gives us the square root of 9, and that does equal 3. But if we substitute a negative number here, that would not work. If we substitute negative 2 for x, we'll get negative 2 plus 6. And negative 2 plus 6 gives us 4. The square root of 4 is not equivalent. It's not equivalent to negative 2. Because remember, you can't have a negative root. Therefore, negative 2 could not be a solution. However, x equals 3 could be. So only one of these checks out. That's x equals 3. All right, in this next example, we see the square root of 5x plus 29 equals x plus 3. So we're going to raise both sides of this equation to the second power, squaring both sides. That removes the square root symbol from the left side of the equation, leaving 5x plus 29. And on the right side, this x plus 3 squared, remember, you're going to use your FOIL method when you're squaring a polynomial. So we multiply the first terms, the outer terms, the inner terms, and the last term. And when we do that, we'll get x times x is x squared. X times 3 gives us 3x. In the center, 3 times x, we'll get another 3x. So that's 2 3x's. We have x squared in front. And then the last term, 3 times 3, that gives us 9. So we combine these two middle terms. 3x plus 3x gives us the 6x. We have x squared in front and 9 at the end. Now we need to combine all of these terms on one side of the equation. Since our leading coefficient, that x to the second power, is positive on the right side, we're going to leave these terms on the right and move the terms that are on the left side to the right side. So we're subtracting 29 and subtracting 5x. That leaves us with 0 on the left side. Over here on the right side, remember, we were subtracting 29 and subtracting 5x. So we carry down our x squared. 6x minus 5x gives us 1x. And the 9 minus 29 gives us negative 20. We factor this trinomial. We're using x and x to factor x squared, and we're using positive 5 and negative 4 to factor negative 20. Now we set both of those factors equal to 0. X plus 5 equals 0, or x minus 4 equals 0. Now we see when we solve these equations, we get positive 4 or negative 5, but that negative 5 doesn't work again. So our only solution would be x equals 4. All right, in this next example, we're solving for b. So we need to remove this square root symbol. So we're going to square both sides of this equation first. Now when we do that, we get x squared on the left side. On the right side, we just remove that square root symbol. We get 2gb divided by w. Now we're going to carry up this w. We're dividing we're dividing right now the w on the right side. So to bring that w from the denominator, we're going to do the opposite, or the inverse operation, which is to multiply both sides by w. That eliminates the w on the right side of the equation, and we're left with 2gb. On the right side, we have x squared times the w. Now remember, our goal is to solve for b, so we're going to get rid of this 2g. We'll divide both sides of this equation by 2g. That'll cancel 2 and g on the right, leaving our solution on the left side, x squared times w divided by 2g. Now in the next example, we're asked to draw a triangle, and we want to draw a right triangle, meaning we have at least one right, well, we have one right angle. And if the lengths of the legs are represented by A and B, and the length of the hypotenuse is C, we're going to place those on that triangle. And so we're just simply drawing ourselves a right triangle. Draw a triangle with a right angle. And when you draw that triangle, you want to label your legs using A and B and your hypotenuse using C. So first identify where your 90-degree angle is. Where's your right angle? Put a box there. The side that's across from that right angle, that's your hypotenuse. That's the side that you should label with letter C. After you label the hypotenuse, then the other two legs, it doesn't matter which ones you choose, are going to be A and B. So you should have a right angle, and then directly across from that right angle, you'll place C for the hypotenuse. You'll place the letters A and B on the other legs. Now from that, you're asked to write and state the Pythagorean theorem. This is the Pythagorean theorem. A squared plus B squared equals C squared. And remember, the A and B stands for the legs. So this is leg squared plus leg squared equals hypotenuse squared. All right, in this next example, determine whether a triangle with these sides, A equals 8, B equals 40, and C equals 41 is a right triangle. If these lengths, 8, 40, and 41, make up a right triangle, then we should be able to substitute those values into the Pythagorean theorem and get a true statement. So that's what you want to do first. Write the Pythagorean theorem, A squared plus B squared equals C squared. Substitute the values that we're given for A, B, and C. So where A is, we're substituting 8. We have 8 squared, that gives us 64. Where B is, we're substituting 40. 40 squared gives us 1600. And where C is, we're substituting 41. 41 squared gives us 1,681. And when we add the left side, is it equivalent? So this question mark is here for us to answer this question. Is the left and right sides equal to each other? And we see that when we add on the left 1,600 plus 64, that gives us 1,064. That 1,664 does not equal 1,681. Therefore, these lengths cannot be a right triangle. We would say no. In the next example, we're told that in a right triangle, we have the length of one of the sides that's not given, and we want to find that length. So we are given A and B. We'll rewrite our Pythagorean theorem, A squared plus B squared equals C squared, and we're substituting the lengths of A and B. So where A is, we put 6, we get 6 squared, that's 36. And where B is, we'll put 10. 10 squared, that gives us 100. And that equals C squared. 100 plus 36 gives us 136. And on the right side, we have C squared. So C squared equals 136. To figure out what C is, the inverse or the opposite operation, we want to take the square root of both sides this time. When we take the square root of C on the right side, we get C of C squared, we get C. And when we take the square root of 36, we get plus or minus square root of 36. The reason why it's plus or minus because we don't know if this number underneath, the number that we squared, was a positive number or a negative number. Because anytime you square a number, you'll wind up with a positive solution, no matter whether that number was positive or negative. So plus or minus the square root of 36 is what we get for C. Now we remove that negative because we know that the square root is only positive value. So C equals the square root of 36. We simplify this square root. Now you can plug in the C equals square root of 136 into your calculator and you can get the decimal form. Another way you can do it is to find the largest perfect square number that can be divided into 136. And 4 goes into 136 34 times. This is equal to 4 times 34. Since we know the square root of 4, we would simply make that calculation. The square root of 4 is 2. Therefore, it's no longer underneath the square root. The 34 stays underneath the square root, and our final answer would be 2 times the square root of 34. Once again, we pulled out the 2 because the square root of 4 is 2. The square root of 34 is not a whole number, so we keep the 34 underneath the square root. All right, in this next example, we have this right triangle where we're given the legs 3 and 3, and our hypotenuse is C. We want to find the length of that hypotenuse, and we want to give an exact answer and an approximated answer to the nearest thousand. Exact answer means to keep that square root symbol. Estimate, of course, we're going to find the decimal form by punching that number into our calculator and round to the nearest thousand. So to find C, we would use the Pythagorean Theorem again. We write that a squared plus b squared equals c squared and substitute our legs, a and b. So where a and b are, we substitute 3. We get 3 squared gives us 9, 3 squared gives us 9, and 9 plus 9 is 18 on the left side. On the right side, we have c squared. To find this solution, we're going to take the square root of the left and the right sides. And we'll get c equals the square root of 18. Remember, we eliminate that negative. So c is the square root of 18. To get our exact answer means keep the square root symbol. Find the largest perfect square number that can be divided evenly into 18, and it's 9. 9 times 2 gives us 18. And since we know the square root of 9, we can pull that out of the square root symbol. Pull that from underneath. The square root of 9 is 3, and we keep the 2 underneath the square root symbol. So our answer in exact form is 3 times the square root of 2. To get the approximate answer, we just simply punch in the square root of 18 into our calculators and round to the nearest thousand. You should get 4.243. So here's your exact answer by keeping the square root. Here's your approximate answer by punching the square root of 18 into your calculator. All right, the next example, we're asked to find the exact length. That means keep our square root and then find the approximate length rounded to 3 decimal places. Now, how long is a wire reaching from the top of a 9-foot pole to a point on the ground that's 6 feet from the pole? So here's the height, and this is the point on the ground that's 6 feet. So we're given this length of 6 feet from that stopping point. We know that we have a 9-foot height. So here's our height of 9 feet. We know we have this length across of 6 feet, and we want to know how long this wire is. So that's our hypotenuse, where x is, since it's across from the 90-degree angle. and we could use Pythagorean theorem to find this length. So our a squared plus b squared equals c squared. We're going to write that Pythagorean theorem again. Substituting the lengths of your legs. Our leg lengths are 9 and 6. So we have 9 squared gives us 81, and 6 squared gives us 36. 81 plus 36 is 117. It equals x squared. Take the square root of both sides of this equation. We'll get x equals plus or minus the square root of 117, but we omitted that negative symbol. So we have x equals the square root of 117. So in exact form, which is part A, we would keep that square root symbol, and we want to find the largest perfect square number that can be divided into 117, and it's 9. 9 times 13 gives us 117. Since we know the square root of 9, we would simply find that calculation. The square root of 9 is 3, and we keep the 13 underneath the square root. The exact answer is 3 times the square root of 13. For part B, the approximate answer, we would punch in the square root of 117 in our calculators and round 3 places after the decimal point. You should get 10.817. All right, so we'll stop here at the last example.